Now we're going to look at something really cool called the Chebyshevs Theorem. And actually this is not normally taught in AP Stats, but this brilliant mathematician discovered that if he was 2 standard deviations away from the mean, he would contain at least 75% of the population. What's amazing about this is this doesn't matter what kind of distribution you have. In the spring I'll teach you about normal distributions, and we'll find out that this is actually 95% for normal distributions, not something you need to know now. But normally we need to know the shape of the distribution. Now the good news is when we do know the shape, we understand even better. So this is sort of a worst case scenario, all right? You might contain more than 75%. So he figured out the worst case scenario. So what does that mean? So let me look at my first period eating habits, all right? We remember they ate an average of 4.5 slices of pizza, and their standard deviation was 2.17 slices. For my imaginary 9th period, these guys ate 5.2 slices. I really should put units. And the standard deviation is 2.2 slices. All right, slices. All right. Where Chebyshevs theorem comes into play, predict what's the range of slices someone might eat. So what I'll do is create an upper. So if I want to know the max, so to speak, which we're really going to change to upper limit, all right, do you think I should add or subtract 2 standard deviations to my mean? Should I add 2 of these or subtract 2 of these from 4.5? Well, hopefully you said add. So what I'm going to do is do 4.5 plus 2 times 2.17. This is my upper. Upper equals, all right. So I'm going to get 4.5 plus 2 times 2.17, 4.34. When I add these together, I get 8.84. All right. My lower, what do you think I should do? Add or subtract? Hopefully, you said subtract. So it's x bar minus standard deviations. In this case, it's going to be 4.5 minus 2 times 2.17, 4.5 minus 0.16, or basically, not 0.16, minus 4.34. I got distracted by the answer. My answer is 0.16. All right? So what does that mean? What that means is that at least 75% of first period eats between 0.16 and 8.84 slices of pizza. Could more kids eat that much pizza? Absolutely. This is a worst case scenario. All right? Worst case scenario. Could I have 26% outside of this range? No, at most outside is 25%. So worst case, we have 75%. Better cases are 80%, 90%, whatever. It's going to depend on your shape. All right? If this was normally distributed, we would actually say 95% for this. But you haven't learned that yet. All right, so let's go ahead and work on it as another example for my 9th period. So we'll do the upper limit for them too. So it's, let me go ahead and write y bar plus 2 standard deviations. The only difference when I write y instead of x is x I'm using for my first set of data and y I'm using for my second set. So that'll equal 5.2 plus 2 times 2.2. 5.2 plus 4.4 is 9.6. All right. Lower equals 5.2 minus 2 times 2.20. So it's 5.2 minus 4.40, which is 0.8. All right. So I can say at least 75% of 9th period eats between 0.8 and 9.6 slices of pizza. All right. Now, he probably thought, hey, I've only got 75% in there. Let's go even further. Let's say I want to get a higher percentage. So he added in these other two ranges. If you go 3 standard deviations, you're going to get at least, that's an X there, 88.9%. And if you go plus or minus 4 standard deviations, you're going to get at least 93.8%. Really pretty cool. So it's meant to capture the big window where you can get most